This is an EEG Basics mini lesson focusing on wickets, sometimes known as wicket spikes. Wickets are a very common normal EEG variant, commonly mistaken for epileptiform discharges. It is important to distinguish wickets from epileptiform discharges so that you don't diagnose somebody with epilepsy who doesn't have it. Here is a screenshot of a normal EEG recording in somebody who is asleep. We know that this patient is asleep because there is no muscle artifact, and we can see some sleep transients, including some posts here and on this side here. The region of interest is in the middle of the screen in the left temporal region. There we can see a run of sharply contoured discharges occurring at approximately 7 or 8 Hz with a subtle increase and then decrease in amplitude over the run. If we look very carefully at the morphology of these discharges, we can see that they have a very simple biphasic morphology. First, there is an upward or negative deflection followed by a downward or positive deflection. The second one has an upward deflection and then a downward positive deflection. And the third has an upward and then downward deflection, and so on. These are very different from epileptiform discharges, which usually have a much more complex morphology, as well as aftercoming slow waves. We can see these wickets more clearly on average reference montage. This confirms that they are maximal in the mid-temporal region at T7. Again we see the run, and again we see the simple biphasic morphology. Wickets can be seen independently in both temporal regions. Here we can see a collection of wickets independently in the right temporal region in the same patient. Again, this occurs in a brief run at approximately 8 Hz or so, and again the wickets have a very simple morphology and do not disrupt the background. If we shift this screenshot to the average reference montage, we can see again the simple up-down or positive-negative morphology, and the fact that the wickets are maximal in the mid-temporal region, in this case at T8. Wickets can occur on their own, and it is sometimes these solitary wickets that are most difficult to distinguish from epileptiform discharges. Here, in the left temporal region, is a single wicket spike standing out from a run of alpha range rhythmic activity. Once again, we can distinguish this from an epileptiform discharge by the fact that it has a simple biphasic morphology, there is no aftercoming slow wave, it does not disrupt the background, and it is maximal in the mid-temporal region during sleep, which is the common place and time to see wicket spikes. If we switch to average reference montage once again, we can see the very simple biphasic morphology of this particular wicket. Here we can compare epileptiform discharges on the top to a wicket spike on the bottom. The most obvious difference between these two discharges is the much more complex morphology of the epileptiform discharge. Here we can see at least 3 phases. An initial negativity or upward deflection, followed by a positivity, then a third negativity, and then an aftercoming slow wave. This has at least 3 phases, if not more, and there is an aftercoming slow wave. If we compare that to the wicket spike, as I mentioned before, this simply has an up, down, or positive-negative morphology, much simpler than the epileptiform discharge. Let's take a moment to summarize and compare wicket spikes to epileptiform discharges. Wickets, as I mentioned before, have a simple morphology, usually 2 phases in a simple up-down configuration as shown here. Epileptiform discharges usually have a complex morphology with 3 or more phases, as shown by this illustration here. Wicket spikes can occur individually or sometimes in runs at 7 to 8 Hz. Here is an example of a run of wicket spikes. Epileptiform discharges, especially focal spikes, are usually solitary, although they can also occur in runs. Wickets do not have an aftercoming slow wave, while epileptiform discharges do have an aftercoming slow. With wickets, there is no disruption of the background rhythm, while epileptiform discharges typically disrupt the background. Wickets typically occur during drowsiness and sleep, but epileptiform discharges can occur in any state. Most importantly, wickets are not associated with epilepsy. It is important to identify wickets and distinguish these from true epileptiform discharges to avoid misdiagnosis.